Okay, let's go through this program. I have these parameters. I have a stock of diameter 154. Total length is 50, that is 15 plus 100 go to 115. Then minor diameter for OD is 105. Then we have a boring internal of the diameter 16, and then we have another diameter 35. Then from there we have face holding, as you can see. So I want to create this program for this one on phase C, drilling using a solid drill for what you call U drill. Then we do another drill for 8.5. We also have M10. U means it M10 by 1.5. Then from there we do threading. Then we do finishing. So let's go to our program. As you can see already, I've just made a simple part here because I didn't want to explain all of the steps. So I've explained here. So our OD, I'm using a diameter for 160 because I have a diameter of 154. So in case I have 155, I can be able to cut it, but I have a diameter of 160. Then the total length for my stock is minus 200. I've clamped it to a length of minus 130. And then because I'm doing boring, I've put here to be extended because I have a boring inside with the retraction X as 5 and then retraction X inside as 25. Then outside for Z as 5, the incremental. But for inside, which is for the drilling, I'm using a U drill of 25. So I'm using a 25 because I have to cut to 25, as you can see. Let me show you. As you can see here, I have a hole. The main hole is 16, and then another one 35. So I'll make a hole of 25, first of all of 16, then from there 25, then from there I can do what you call boring. And then I'm teaching my point to be at the safe point or far away from where the tool will be able to change. And then from there I have what you call down cut. And then this is what I did. Then from there I did what you call face cutting. So face cutting, I'm using an OD tool. So this is my tool, list I've created, OD tools. With the feed rate of 0.25 millimeter per revolution, then with a cutting speed of 150, which can even go to 140, but 150 is okay. Facing, the diameter for facing is 160 with a 1 millimeter excess for facing. Then I'm using the depth of cut each time as 0.35. Then from there I have done my contour. So this is the contour. As you can see the drawing, how the drawing look like. Let me show you the drawing. So this is the drawing. You come from this point, it goes all the way, then it goes away. So this is a drawing. From this drawing, you're able to see that I've created this part. So that's the part. The starting point I did what you call 105 with a radius of 2.5. Then I went to minus 100 with a radius of 2. Then at the end, I went to 160. Then that's what I did. Then from there, I did the stock removal OD rough as complete, with a feed rate of 0.3 millimeter per revolution with a cutting speed of 150. Then this is OD, depth of cut each time I'm removing 6 material or 6 millimeter. Then diameter for my stock is 160. So this is what I did. If I had undercut here, I don't have undercut, so that's why I did it blank. Then from there, I want to do what you call center drilling. I have a twist drill which is fixed axial at diameter 16. I'm using a solid drill, or even twist drill, it's okay, but I'm using a twist drill of diameter 16. Why I'm using twist drill? This hole is 16, but it's through hole, so that's why I'm putting through hole. And then it goes all the way to minus. I'm using tip to minus 120. Then from there I'm going to do another hole drill using solid drill 25 complete. Why 25? Because I don't have a tool for 25 for 35, so I did 25. Then the main material I'll do what you call internal boring or turning. I went to minus 64. So how do I get 64? As from here you can see it's 115. So 115 minus 15 will get close to 65, but it doesn't go all the way. So I want it to come to almost somewhere here, not all of it. And then I went to now pocket on this face. As you can see from this face, I have this pocket, this small pocket. This is what I did. So using an end mill of diameter 8. Okay, I can use even more than the 8 because the hole is bigger with on the face. So I'm using on the face, not per surface. It's a single. The diameter is 50. As you can see, I can show you the diameter here. This is the diameter 50, so it is on diameter 50, and then it has this depth going inside -7. Then I'm cutting it once. Then from there I exit it. Then from there I went to a second contour. My second contour is now internal. Let me show you from the drawing. I'm doing now internal. From this point, I just wanted to go straight because already I've done my pocket here. I'm just going straight from this point. I go all the way to minus this point. That is 15 plus 15, or rather from this point up to this point. I'm able to calculate from 100. I can say this 100 minus 16, or I can say 35 plus 16 from 115. I'm able to get the distance from this point. So that's why I went all the way to Z minus 64. Okay, then I went ahead to do finishing for internal. I can come to do finishing at the end of it. So maybe, for example, I definish. I'm using the same tool for turning and finishing. Same tool for turning and finishing. Then I went ahead to do another deep hole drilling. Why deep hole drilling? I want to get these holes. So I'm using deep hole drilling. There are how many holes? There are 4. 1, 2, 3, 4. Deep hole drilling, as you can see from this point. So I'm using deep hole drilling. Let me show you the program. That is deep hole drilling. There are how many on the graphic for deep hole drilling? You can see. Let me show you the deep hole drilling. Then the points. How many points are there? There are 4. 1, 2, 3, 4 at an angle of 45 degree. An angle of 45 degree. Okay, as you can see, that's the angle of put. Then second, thread milling now, because in the drawing here, as you can see, we're drawing half M10. So this M10 by 1.5, which goes to -20. So I have put here from starting from 0, going inside. As you can see here, you have right hand thread, internal thread, number of thread. I'm putting 2. Then is ISO. I've just put from the table ISO. The table here, I'm using M10. As you can see, I'm using M10. Then pitch is 1.5 with the diameter for 10. Then height, which is 0.265 times the pitch. Then here incremental of 1. I'm just using 0.1 millimeter. The angle in between, I can put it even 30, for example, or rotation. That's okay. Then I can able to calculate. Then this, how many points? There are 4 of them. So you need to put the location for the hole. The same point that is here. So that I just copy this and then put here because it should be the same point, because where I'm doing threading. Then I came to end mill slot. End mill slot. I have at this point where I went to have a pattern. You see now here I changed to pattern instead of single to pattern. But in this pattern I came to put a location at -30. I'm gonna start with an angle of 33 of them. Then I get another end mill slot on the per surface. The same dimension, but I change the angle here and the length. You see, I change the angle as to from 45 now it goes to 90, but it goes inside -60. Then from there I need to create a second contour for finishing operations. So these are finishing operations. If I right now do a simulation, you're able to see it's not all possible with the turning tools. Why? This for stock removal. Stock removal, I need to change the tool because I have already changed the tool. So that's why I was trying to explain for OD. I can put this tool, okay, because I was trying to explain and the tool was changing. So I can do a simulation. You will see what will happen when it is cutting. This is for what you call turning. So this is ShopTurn. So you can see it's doing facing. From facing, let me do side view, further view, then I want to have view. You can see drilling inside. That is the drilling for diameter 16. Then it comes to diameter 25. That is solid drill. Then it comes to do pocket, first pocket. Let me do 3D. You see, this is the first pocket. I can increase this. You can see the first pocket. Is doing the first pocket. I can delete some of it. Okay, let me just leave it the way it is. Then this is the drilling. From this drilling, that is deep hole drilling, it will do threading. You see now it's doing threading. What you call thread milling. It is doing thread milling. As you can see, it's doing thread milling. Yes, this is thread milling. It has finished. It goes to the second slot. So it's now the first slot, sorry, first slot, or position 1 for first slot, position 1. First slot, position 1. I can increase override to 100%. You're able to see how it cuts. So this is the power of Siemens 840 or 828 using what you call ShopTurn programming. ShopTurn programming, and you will see the final part. So this for on part A. I can able to change the other part to cut now the remaining piece, which is on the taper side. You see, I can even put it to maximum override. You will be able to see what will happen when it is cutting, or just normal override, so that you can see how it cuts. So this is what you call ShopTurn programming. As you can see what is cutting. ShopTurn programming. Input maximum override. You can see finishing. So I will do the other side, but remember you need to cut the exact material, so that when you are doing this turning, I can start with the other side. For example, I can do the other side, and then once I finish, I turn this side, so that I can now do the remaining on this side to make it easier for me to cut. So you see the slot, how I change the positions. You can see how I change the positions. Then the last one is finishing. This is how you able to play with their programming. This is what is supposed to be produced on the machine, as you can see. But the other slots I've just added for the best way of explaining how to do what called ShopTurn.